Okay, so 6-3, the top of it there, we're solving the quadratic equations by factoring. So the zero product property says, if I'm multiplying two things together and I get 0, well, then either A has to be 0 or B has to be 0 or both of them, right? When I'm multiplying two things, no matter what they are, one of them has to be 0 in order for me to get 0. Or 0 times 0 equals 0. Okay, so we're going to solve by factoring. So, rewind your brain. Remember the sign chart? I have them there just for reference for us. Okay, when we're solving any of these, we have to get everything on one side of the equal sign. He has to be equal to 0. Okay, well, I'm going to move the 4x to the other side. So I get x squared plus 4x equals 0. So everything has to be on one side equal sign. He has to be equal to 0. All right, and then remember the very first thing we always do when we are factoring is we look to see if they have anything in common. Do x squared and 4x have anything in common? An x. Let's pull it out front. So that I'm left with x times x minus, or plus 4. X plus 4. And then I'm going to use that zero product property that says when I'm multiplying two things together and they equal 0, well, one or both of them have to be equal to 0. So I'm going to set each equal to 0. Okay, so x equals 0 or x plus 4 equals 0. And then I solve for x. Well, looky there, that guy's already solved for x. So x is 0. Or x equals what? Negative 4. Now, you factored this guy and you found out he had two solutions. But you weren't quite sure you did it right because you're like, factoring isn't my most favorite thing to do. So how could you check it? You could plug them in, right? Is 0 squared equal to negative 4 times 0? Yeah, okay. So is negative 4 squared equal to negative 4 times negative 4? Yeah, they're both equal to 16. What else could you do? Thomas.
I don't know.
It escaped. It ran away. What do you have? What did you just do? How did you just solve them? You graphed them, right? Could I throw that guy in my calculator even though it doesn't tell me to? Can I use my calculator? Yeah, that's okay. It's yours. Okay? So what if we just graph that guy and see where he crosses the x-axis? He should cross at 0 and negative 4, right? Okay, let me show you. X squared plus 4x. Well, there's negative 4 and there's positive 0. Positive 0. Good grief, lady. There's negative 4 on my chart, on my table, and there's 0. You should be seeing the same things whether you do them from factoring or you do them from graphing. Okay? Now, if it tells you to factor, I actually want to see the work for factoring, so don't just go ahead and graph everything. Okay? Okay, so let's look at number 2. Questions about that? All right, so first thing, we got to get everything on one side of the equal sign. Well, it's a whole lot easier to factor when the squared term is positive, right? So let's move the 5 and the 5x and the 2. So 3x squared minus 5x plus 2. Yeah, you're like, thanks. I don't know what I'd do without you today, Thomas. My signs would be all messed up. Okay, now what do? What are my signs going to be? Minus plus, okay. I also have a coefficient out front, so I need to put a 3x minus 3x plus. Let's do our magic x. What goes in the top? 6. 3 times 2 is 6. What goes in the bottom? 5. I need two numbers that multiply to 6. These signs are different, so they subtract to give you 5. Be careful. They multiply to 6. Yeah, 6 and 1, right? Be careful, 2 and 3 will subtract to give you 1. I want a negative 5, so I need a negative 6. Remember, I put that 3 in there too many times, so I need to get rid of him and throw him in the trash. 3 and 6 have a 3 in common, so this guy is now x minus 2. 3 and 1 don't have anything but 1 in common. Now I'm going to set them each equal to 0, so x minus 2 equals 0. 3x plus 1 equals 0. And solve for x. X equals 2. 3x equals a negative 1. So x equals negative 1/3. Leave it as a fraction. Oops, sorry. Okay, questions on any of those? So if we graph that guy, and you can do it if you want, he would cross head positive 2 and negative 1/3. Okay, number 3. X squared minus 6x equals a negative 9. What do I need to do first? He has to be equal to 0. So x squared minus 6x plus 9 equals 0. I have a minus and a plus. Thankfully, there's no number out front. They multiply to 9 and add up to 6, so 3 and 3. Set each one of my factors equal to 0. So x minus 3 equals 0, or x minus 3 equals 0. So x equals 3, or x equals 3. Well, that looks kind of weird. What's going on there? Thomas, what do you think? Yeah, we only get one solution. Remember when we graphed those guys, and our vertex is sitting on our x-axis, we only get one solution. So technically, this guy actually has 2, but they're the same. We call this guy a double root. The vertex is on the x-axis. Yeah, fine.
For n number, should we do like both or?
You can just do one. Yeah, that's fine. So remember, I told you when we started graphing, you could have one solution, two solutions, or no solutions. This guy is the one where he has one solution, and x equals 3. Oh boy, number 4, those numbers look big. Let's do it together. What do I have to do first? Equals 0, right? Move the 27. Do 16, 48, and 27 have anything in common? Unfortunately, no. Alrighty, here we go. Head first. I have a minus and a plus, so it's going to be a minus and a minus. Okay, my magic X. What goes in the top? I have a coefficient of 16, so what do I have to remember to do? Multiply 27 and 16. Well, I'd like to say I would know that one. 432, right? 48 goes in the bottom. I don't know about you, but I'm not up on my factors of 432. You remember the trick to finding your factors?
Y equals, and then you do 432 divided by x.
Awesome. Thank you, Abigail. You go to y equals 432 divided by x. And then we're going to look at our table. I want two numbers that multiply to 432. The signs are the same, so they need to add to 48. Oh, hey, look, there's 9 and 48, but that doesn't add to 48. Find it? What is it, Thomas? 12 and 36. Now, we normally would trash at this point. I want to let you know if you forget to trash, that's fine. Because it'll work itself out as you're solving these guys. But now I'm going to trash these guys if they have anything in common. Do 16 and 36 have anything in common? A 4. Take it out and throw it in the trash. So this guy is 4x minus 9. How about 16 and 12? 2, anything bigger? 4. Set them equal to 0. Leave them in fraction form. So 4x is equal to a positive 9. So x is equal to 9/4. 4x is equal to a positive 3. So x is equal to 3/4. Okay, so far in our toolbox, we have two methods to solving. You can graph them and see where they cross the x-axis. You can factor them, set each factor equal to 0, and then solve them. Okay? Questions on that? Okay, so let's look at your worksheet before I do 5 and 6 because that's like going in reverse. So let's look at your worksheet. Solving by factoring. Trying to decide here. That's what I was thinking about, but I want you to have the practice. Yes, I'd be okay with that. You can pick a column. Okay? Now, if you're struggling factoring, I would suggest you do all of it. The only way to get better at math is to do more of it. Okay, so...
What about 25?
25 you can skip. At the moment, you can only do 1 through 18. I haven't talked to you about 19 through 24. So skip 25. But let's look at number 2. Because we didn't have one of those on your notes. What is that guy? It's a special name. He's a perfect square, right? He's the difference of squares. Do you remember how to factor a difference of squares? There's a plus and a minus. So he'd be plus 10, x minus 10, right? So you take the square root of both. Square root of x squared is x. Square root of 100 is 10. Set them both equal to 0, so x is negative 10 or positive 10. Make sure if he's not equal to 0, like number 14, number 11, that you get them equal to 0 before you start factoring. Okay? Yes, you may pick a column. I don't care which one. Okie dokie. Alright, now, let's go back and talk about number 5 and number 6. Number 5 says, write a quadratic equation with negative 2 and positive 6 as its roots. Write the equation of the form ax squared plus bx plus c, where a, b, and c are integers. That means no decimals and no fractions. This guy is telling you the answers. The roots, solutions, zeros. Remember, those all mean the same thing. So the answers are negative 2 and 6. I want you to tell me what the equation is. So we're working backwards. Okay? I'm telling you the answers. You're going to give me the equation. Okay. Well, if the answers are negative 2 and positive 6, let's look about what we did going backwards. Maybe a better one would be this guy up here. What did we do if we're going to go backwards? I have the answers here. What did we do? Thomas.
We did the factoring, but
What are they both equal to?
0.
0, right? Okay, so we got everything on one side, and we set them equal to 0. And if I'm going to go from this guy up to that guy, what am I doing? What's the opposite of factoring? I heard it. At least I thought I heard it. How do I check it? If I were to factor that, how would I check it to make sure that that's the right answer? Foiling. Oh, yeah, right? Remember that?
Yeah, no, I would never guess that one.
So I'm going to write them, I'm going to get everything on one side equal sign. I'm going to write them as factors. I'm going to FOIL it, and I'm going to get an equation. Okay, so let's move this guy to the other side of the equal sign. Let's set him equal to 0. So if I move this guy to the other side, what do I get? X plus 2, right? And technically he equals 0 at the moment. And what happens if I move the 6 to the other side? X minus 6 equals 0. And now let's write them as factors. If you notice, all we did was flip their sign. This guy was a negative 2. He's a positive 2. This guy was a positive 6. In my parentheses, he's a negative 6. See that? And now I'm going to FOIL. So, x squared minus 6x plus 2x minus 12 combine like terms, so x squared minus 4x minus 12 equals 0.
And that's it.
That's it.
Oh goodness. Look at that.
It's not horrible, right? Wasn't too bad.
I wouldn't consider it fucking. That's just my honest opinion.
That's
But
okay.
it's interesting.
You went backwards, right?
Yeah.
We undid it. Okay, so that one wasn't too crazy. Just take a look at it, for example, at number 4. We got fraction answers, right? Did our equation, though, have fraction coefficients? No. Okay, so look at 6. He says, write the quadratic equation with negative 2/3 and 7 as its roots. Okay, let's write that as x equals negative 2/3 and x equals 7. Well, it says no fractions and no decimals, so I don't want fraction or decimal coefficients because that would look really weird. But let's look at this guy. I got a fraction over here. Where was that 4 from? What happened with that 4?
Oh, you divided it.
We divided him, so he was the coefficient of who? The x, right? Okay, so if I have a 3 over here, that's really 3x equals a negative 2.
And then it's 3x plus 2.
Perfect. 3x plus 2 equals 0.
And x minus 7.
So my factors are 3x plus 2 and x minus 7.
Foil.
FOIL. So 3x squared minus 21x plus 2x minus 14. So 3x squared minus 19x minus 14.
Okay, that's fine.
Okay, so you have 3 of those on your worksheet. So if you look at in your worksheet, again, just decide a column to do. 23 and 24, you should not have fractions. Okay? So on these guys, you're going to be writing the equation. Questions so far?
It's pick a column.
Pick a column, the whole thing.
Okay.
You can do odds or evens, I don't care.